All right, so we got our 2 rules. Rule number 3, if you're interested in copying it down, feel free to, because this is the one rule that they will always use. I promise you 100%. If they're going to have one in the exam, it's based on this rule. Most students remember the first 2, and then they screw up with the first 2 because they throw in a rule number 3. If you don't do the rule number 3 to change the problem, and you try to apply 1 and 2, that's where you go wrong. That's the misconception. So that's what the textbooks won't tell you, and that's what my experience will be able to tell you. That law number 1, law number 2, you will remember this. This is the common thing in the state. What the state doesn't generally do is they don't know how to apply rule number 3. Okay, so there's misconceptions, and I'll show you some examples when we're doing the exam questions. I'll show you what are the common ones why students are getting it wrong, when technically you should be able to get them right. Okay, so we'll have a look at it soon. But right now I just want you to copy number 1, number 2. If you're happy, then copy number 3. But number 1 and 2, you must know at this point. What I'm going to show you next is I'm going to demystify this idea of memorizing logs, or like what is a log. I'm going to show you some examples, and hopefully I'm going to show it on the calculator so you can see the pattern to it, because it's exactly the same as what you've been doing in year 7. It just looks different. Okay, it just looks different. Here we go. Let's do this. This is the exciting part. When you're working with logarithms, I find that students get confused on what it actually is, right? This is how I like to show it. Let's say I gave you, I'm just thinking whether I should use x. I'm going to use x for now. No, I'm going to use 5 actually. All right, I'll use 5. If I use 5, and I say this to you, I am going to add 3 and then subtract 3. What's my answer? 5. Very good. If I use 5 again, and I said I am going to times 3 and then divide 3, what do I get? 5. If I use 5 and I say divide 3 and then times 3, what do I get? 5. There's a pattern here, and you picked up on this really quick, true? But this is where it's interesting. So you guys know how to do this so easily, but as soon as I switch it to exponential logs, this is where students find it hard. But the theory isn't different. I went from add to subtract, because subtraction is the inverse of addition. I went from times to divide, or divide and times. They're the same thing. So the reason why you find this easy is because you're used to seeing a symbol and a unit. But it's no different when it comes to exponentials. So I'm going to show you the look of an exponential now. This is the same idea. Okay, same idea. So exponentials is to the power of. Okay? This is where it might be confusing when I write the letters. So here we go. I've got 3 to the power of 5. Okay? Now, maybe I'll choose a different number. I'll change all of this to 2s, just to make it easier. 2, 2, 2, 2, 2, 2. What's 2 to the power of 5? 32. Okay. Now, this is where I'm interested in. This is why it gets confusing. So the 32 is kind of like saying 5 times 2 is 10, right? Now I'm going to reverse this. How do I reverse it? It's the same thing here. So 2 to the power of 5 was the operation. I'm going to highlight it. This is my operation. And logarithms is the inverse. So if I were to reverse this, I would write this. Log. Now because I use the number 2, I'll be doing log base 2 of this. This is why students get confused. You see the difference between the two? You're used to seeing this. Add, opposite of that is subtract. Times, opposite of that is divide. I kept the 2s. They're all there. I'm keeping the 2s. I haven't changed the 2s. They're still there. But the sign is different. You don't see the sign anymore. That's why students can't compute the 2, but they're the same thing. You see here, the 2 being in the base value and then to the power of 5, that's my sign. That's the operation. That's what I'm doing. I'm doing 2 to the power of 5. That's exponential. Then the opposite of exponential, just like the division, the opposite of times, it's my log. Log is the symbol. It doesn't look it, but it is. L-O-G is the symbol, and the 2 is what I'm doing here. So divide 2. So if you can see the relationship between the two, we know the answer still has to be 5, and I'm going to show you. Okay, so we're going to go in our calculator. Let's have a look. I'm going to go to my calc. I'm going to do the same thing. So 2 to the power 5, you're right, it's 32. But if I now try, so on your calculator, you see over here with a 10 to the power of x, I do control 10 to the power of x, log base 2 of 2 to the power of 5, okay, so that's what we were writing before. They're meant to be inverses of another. It's 5. Because that's the thing, I'm doing it. That's all I'm doing. I'm doing 2 to the power of 5, and then I'm saying, well, 2 to the power of something equals 32. What is that? And it goes back to 5. Just like how you would do 5 times 2 and then divide 2, you get 5. 5 plus 2 minus 2, you still get 5. What I'm doing the 5 here is I'm doing 2 to the power of 5. That's the exponential. That's why students get confused here. I'm doing an operation. What is it? Exponential. I'm doing a base 2. That's the number. And then how do I reverse that? What's the opposite of exponential? It is logarithmic. I have to do it this way. Logarithmic. Oh, no. Control 10, log base 2 of 2 to the power of 5. What I'm actually doing there is I'm taking my 5. So you need to look at it as just like you did over here. 5, I'm timesing the 2, then the opposite of that was divide 2. 5, I'm adding the 2, then I'm subtracting 2. Here, 2 is the base. That's an exponential. That's the operation. And the 2 is the unit. How do I get rid of that? The opposite of that, which is log. Now, if that's a 2, to get rid of that, I would be doing log base 2, just like how I would have done divide and addition. So I can see why. Can you see why the state gets confused here, where they're saying, I know how to do these, but when I give them that, that's when they get confused. But the answer's still the same. I'm just undoing the answer, hence why it's 5. Now, the reason why I want you to understand this is because I don't want you to memorize this rule that I learned when I was in high school as well. In high school, they teach you how to convert an exponential to a log. So, for example, if you know 2 to the power of 5 is equal to 32, okay, there's a rule where you can simply convert an exponential to a logarithmic, okay, and this is what it'll look like. It'll look like log base 2 of 32 equals 5. And this is what they teach you in high school normally. So in most schools, most students will know this sort of conversion. You'll probably find on YouTube as well. They'll say you swap the 5 and 32 and the 2 goes down. Okay, and that's one way of memorizing it. So if I gave you a formula for this, you could have a to the power of m equals to n as an example. Then it would be log base a of n is equal to m. So you can copy this one down, but I'm going to show you why this works. Because if you get it, then you won't get confused here, and then you won't find logarithms hard. But you can copy that for now just to work on the questions. But I'm going to show you why this works, okay? Because it's all inverse operations. That's all it is. Whatever you did in year 7, you're doing the same thing in year 11, just a new topic, a new the opposite of indices. That's all it is, okay? So if you think about BODMAS, you have learnt opposite of addition, opposite of subtraction. You have learnt opposite of division and opposite of multiplication. What you're missing is orders of operation, the order, the power. You haven't figured out or haven't been taught what is the opposite of indices. And that's where logarithms come in. Okay? So, here we go. Let's show you the logic to where this comes from. You don't need to memorize this step here and move those numbers around. Because if you get it, that's where, if you have a look in your, where's your question? Here we go. In your sheet that I printed out for you, see question 9 on the back? That one? That question 9, there is an orders change of bases formula. If I'm correct, there's another one in 2021 or somewhere closer to those years. That type of problem is normally answered about maybe less than 20% of students get it right because of that simple idea, what I'm teaching you there. Okay, so if you get that, you should be able to tackle that problem with a CAS and you'll be able to tell which one is the correct answer. Okay, but here we go. I'm going to show you the theory. Have a look. You got 2 to the power 5 equals 32. And this is what you're memorizing. See, I'm not about memorizing, I'm about you understanding how this comes about. This is where it comes about. It's a very simple idea as well. You have 2 to the power 5. I'm going to do x here now, equals to 32. This is a problem. That's a typical problem that you might get. So you want to solve this problem. We know the answer is 5, right? Just like if I gave you 2 times magic box equals 10, you know the answer is 5, right? The question is, how do you solve it? This is what you would have done back in year 7. If I put an x here, you would say, how do you find x? You would say opposite of times, divide both sides by 2. Correct? That's how you would have done it. And you would have then said x equals to 5, if that was the equation. Then in this problem here, it is no different. You see, if you know that this is x is what you want to find, how do you get rid of exponential? The opposite of exponential is log. So I need to do log base what? Because this is a 2, I'm doing log base 2, both sides. See, that's a key sentence there. I'm going to do it to both sides, just like you would with inverse operations with times. The opposite of times is divide. You divide both sides by 2. Here, this is what I'm doing. I'm going to do log base 2 of the left-hand side, and I'm also going to do log base 2 of the right-hand side. So I'm balancing it. So what's on the right-hand side? I have 32. What's on the left-hand side? I have 2 to the power of x. Now we know before, what did I show you before? I showed you that when you have 2 to the power of x, and you do log base 2 of that, you're just inversing each other. Just like how you had this line up here. Where did I do it? Up here, we knew they're all going to cancel each other out. So your final answer has to be exactly what you started off with. So here, I can say log 2 of 2 on this left-hand side, this one right here, whoops, not that one. Let me highlight it again. This one right here, what does that equal to? X. This breaks down to just x, because log 2 and 2 are inverses of one another. So they would cancel out, and you're left with just x. And here we go. Have a look at that. X equals 2 log base 2 of 32, and have a look at that. Look at my rule. X equals 2 log base 2 of 32 is exactly what I have over here. X was 5. 5 equals to log base 2 of 32. So if I type it on my calculator now, have a look. If I go to my calculator, I go control log base 2 of 32 equals 5. Because that's all I'm doing. I'm not doing any conversions. I'm not memorizing any conversions. All I'm doing is inverse operations. Okay, so have a look. Let's go through another one. This is from 13F. Okay, 13F. I'm going to show you how to solve these problems here. So they want you in 13F. Let's have a look. 13F, you got some exponential problems here. Your goal is to find x. So here I have 2 to the power of x equals 7. I want to find x. Just like how you always normally do it with other inverse operations, I want to get rid of that 2. How do I get rid of that 2? What would I have to do? Yeah, log base 2 on both sides, because that's the inverse operations. That's what you do. So here we go. I'm going to say, all right, let's log base 2 on both sides. And a log base 2 on the right-hand side. Can you see? I now just have log 2 of 2 are inverses of another. They cancel out. And what do you get? X equals 2 log base 2 of 7. How easy is that? So when they say to you, they want you to calculate correct to 2 decimal places, you're typing this on a calculator. You understand that log 2 of 7 is simply finding x. It's the power. So it's just the inverse. So you're used to indices where 2 to the power of 3 equals 8. You know how to do 2 to the power of 3, but what about the reverse? 2 to the power of what gives you 8? Well then, if I were to write it in logarithmic sense, it would look like this. Log base 2 of 8 is equal to 3. Because when you read the word log, what that's trying to say to you is 2 to the power of what gives you 8. That's what you're doing. You're calculating for the power. See, whereas exponentials, you're calculating for the value. You're saying 2 to the power of 3, what does that equal to? Logarithms is the reverse. Logarithms saying, well, 2 to the power of what gives you 8? That's what they're looking for. And the reason why I asked you not to remember the last 2 rules, so remember the logarithms, there were 5 rules. True? Let's have a look at your logarithm rules now. If you get what I'm saying, you can then see why I don't want you to memorize these 2 rules here. Law number 5. If we actually read this, what is that actually saying? It's saying a to the power of 0 equals 1. Is that true? A to the power of 0? Yes, it does, because that's all it's doing. It's trying to say to you, a to the power of 1 is a. That's true. So you know how to read exponential. And that's why I'm saying the stronger your exponential rules are, when you convert them and you understand what it means, the logarithms aren't scary. It's to understand that a to the power of something has to equal to 1. What would it have to be? It has to be 0. A to the power of what gives you a? It has to be 1. A to the power of 1 is itself. So if you understand that, you don't need to memorize law 5, which some students do. And the problem with memorizing is you mix these 2 rules. So sometimes you can probably ask a year 12 currently, and you say to them, what is log of, 5, log base 5 of 1? Some of them may say 0 or 1, because they're trying to memorize which one is it. Is it a 0 or is it a 1? Okay, you're not meant to memorize, you're meant to understand. If I asked you what log base 5 with 1, what that equals to, all I'm asking is 5 to the power of what equals 1? And the answer should be 0. See, if you get it, if you can interpret it, it's not a hard question. It's the way it looks. The way it looks scary, but you shouldn't be trying to memorize whether it's going to equal to 1 or whether it's going to equal to 0. Because as soon as you start doing that, you're not understanding the logic to it. It's just inverse operations. That's all it is. So the better your exponential indices, the easier it is to answer these questions. Okay? Now, let's give you some examples to do with the 2 rules that you've learned so that you can start practicing. You probably can't tackle this yet until you get used to the rules and the conversion. So we're going to get you to practice in exercise 13E. Let's pick some questions to do now. Okay, so let's have a look. It says here, now that you understand the conversion, let's see how much you understand. 1A. It says, without using a calculator, they want you to evaluate log base 2 of 128 without using a calculator. What I want you to think about is, what is this question really asking? What is this question really asking? What are you trying to figure out?
What times 2 to the power of something equals 128?
Very good. So write it down. So my step for you, my advice for you is to write it down. 2 to the power of what will equal 128? Suddenly, you've converted this logarithmic problem into an exponential problem. This is an exercise 13D problem. Hence why, if you practice your 13D, you should be able to answer this question. See, if you have a look at 13D, I'm going to jump back to 13D, you can see the similarities. Look at 13D. Doesn't that look similar? That's all you're doing. You're practicing 13D. That's why if your 13D is good, then when you do logarithms, you're up to this problem. How would you do that? Well, 2 to the power of x, I can do a factor tree for 128. So 128, let's break it down. 2 numbers that multiply to give you 128, what would that be?
64 and 2.
Very good, 64 and 2. You can break the 64 into 8 and 8. 8 and 8 can be broken up into 4 and 2. 4 can be broken up 2 and 2. And same thing, 4 and 2. 2 and 2, so how many 2s? 1, 2, 3, 4, 5, 6, 7. So it should be 7 to the power, 2 to the power of 7 will give you 128. So I know, if I write it down, that's 2 to the power of 7 is 128. Now I know bases are the same, therefore powers are the same. So you can say here, therefore x equals 7 without using a calculator. Okay? But all I did was I interpreted what this means. That's the key thing I'm trying to teach you. Interpret what the logarithm means. Write it down. Because once you do, it's all exponential problems. That's what it is. Okay, so your exam questions, they're trying to build up on your exponential equations. If they give you a log problem, it's your exponential rules. If they give you exponential rules, then it's your logarithmic rules. Okay, so that's how you got to work between them. So let's pick another one. It's all about interpretation here. Let's say this one. That's a good one. without a calculator, log base 10 of 0.1. Start by asking, what does that mean? Okay, so think in your mind, what is it really asking? So what's this question really asking me right now?
To the what equals 1.
Very good. This is, you're looking for the power. 10 to the power of what is equal to 0.1. And then from here, this is your exercise 13D problem. It's about you being able to convert 0.1 into something that you can solve. And for some of you who don't know how to do this, converting 0.1, that is the same thing as 1 out of 10. That's 1/10. That's the same thing as writing 10 to the power of negative 1. And over here, you've got 10 to the power of x. So therefore, x must equal to negative 1. Okay, so this is all going back to 13D. You got to be good with your exponential equations to solve these problems here. Okay, so I'm going to give you just some time. Have a practice with some of these rules. So A is conversion. I taught you law 1 and law 2. I want you to practice doing these ones here. So using that, get familiar with the rules. What would it simplify to? Because you're not solving yet, you're just simplifying. Okay, using law 1, law 2. To do law number 3, we'll talk about that soon, but I'm going to give you some time just to do law number 1, law number 2, and then in question 3, I want you to evaluate without using a calculator the techniques I just showed you. Question 3, have a go. So if you break that apart, convert each and every one of them